Dogs have been banned from Antarctica since 1994 due to fears that they could spread diseases to the native seal population. Though dogs were instrumental in early Antarctic expeditions, enabling explorers like Roald Amundsen to navigate the treacherous terrain and reach the South Pole, they were banned from the continent in the early 1990s as part of the Antarctic Treaty. This decision was driven by concerns that diseases carried by dogs, such as canine distemper, could potentially spread to the native seal population, posing a serious threat to the delicate Antarctic ecosystem. Canine distemper is a highly contagious viral disease that affects a wide range of animals, causing respiratory, gastrointestinal, and neurological symptoms. Given the genetic similarities between dogs and seals, there were serious concerns that the virus could mutate and jump the species barrier, potentially leading to widespread outbreaks and even extinction among seal populations. This potential for ecological disruption prompted the Antarctic Treaty nations to take proactive measures, prioritizing the preservation of the continent's unique biodiversity by removing all non-indigenous species, including the beloved sled dogs. The removal of dogs marked the end of an era in Antarctic exploration, one in which these hardy animals were vital companions and work partners, enduring the harsh conditions alongside their human counterparts. The legacy of these canine explorers remains, however, in the form of place names, old photographs, and even the preserved remains of dogs from past expeditions, frozen in time and emerging from the melting ice each spring.
Around 700 million years ago, our entire planet, from pole to equator, was covered in ice in what's known as snowball Earth. The theory suggests that during this period, a glistening, ice-covered Earth would have been visible from space. But what triggered such extreme drops in global temperature? One theory blames a decrease in atmospheric carbon dioxide, a potent greenhouse gas, potentially caused by the proliferation of photosynthetic organisms drawing it out of the air. This led to runaway cooling, as the Earth's surface, now covered in reflective ice, bounced more sunlight back into space. This ice-albedo feedback loop could have plunged the planet into a deep freeze. With volcanic activity continuing to pump greenhouse gases into the atmosphere, the frozen world eventually began to thaw. Carbon dioxide built up over millennia, eventually reaching levels that overwhelmed the reflective power of the remaining ice. The planet rapidly warmed in a massive greenhouse effect, melting the global ice sheets. Evidence for this dramatic about-face comes from thick layers of carbonate rocks found directly above glacial deposits, laid down as the excess carbon dioxide was reabsorbed by the oceans. These snowball Earth episodes may have had profound consequences for life's evolution. The harsh conditions would have acted as a brutal evolutionary bottleneck, wiping out many lineages and forcing survivors to adapt. Some scientists believe that the events of snowball Earth might have triggered the sudden increase of diverse life forms during the Cambrian explosion.
A single cloud can weigh over around 1 million pounds. Despite their ethereal appearance, clouds indeed possess weight due to the density of their particles. Clouds don't have a fixed weight since their weight depends on various factors, including their size, altitude, and the amount of water vapor they contain. However, it's estimated that a typical cumulus cloud, which is a fluffy white cloud often seen on sunny days, can weigh around 1.1 million pounds, approximately 551 tons, for a 1 cubic kilometer volume. That's roughly equivalent to the weight of the world's largest aircraft at full capacity, with both cargo and passengers on board. This weight is due to the combined mass of the water droplets and ice crystals that make up the cloud. Despite their apparent weight, clouds float in the sky because their density is lower than that of the surrounding air, allowing them to remain aloft. Larger clouds with more moisture will be heavier than smaller ones. Weather conditions, altitude, and temperature also play roles in determining cloud weight. In scientific research, understanding cloud weight helps meteorologists and atmospheric scientists study weather patterns, cloud behavior, and their impact on Earth's climate system.